All right, our last video for section 2 starts off by looking at our quadrilateral hierarchy. Basically what that says, it's just kind of a flow chart or a diagram showing all of the figures that are possibly quadrilaterals. So quadrilateral is our main piece. They don't have this drawn on there. I want you to draw in an extra arrow off to the side because we could have irregular quadrilaterals. Now this one again has to be drawn in a way that it doesn't fit parallelograms, kites, or trapezoids. So irregular is still a possible kind of quadrilateral. It just, there's no rules to it. The only rule for it is it has to have 4 sides. Moving down our hierarchy though, our flow chart, one branch over here is the trapezoids. Okay, so our trapezoids, remember, the only thing we know for sure is that this is parallel to this. There's only one pair of parallel sides, or there's 2 parallel sides, not 4. Okay, now trapezoid kind of breaks off into isosceles trapezoids and right trapezoids. Isosceles, we went over, found some things about those. A right trapezoid, really the only thing you need to know about that is it's any trapezoid that would have 2 right angles in it. That's the only difference. Okay, and again, there's nothing necessarily special about the right trapezoid except it has these right angles. Okay, continuing to look at our flow chart, our hierarchy. Quadrilateral is our main thing. Everything on here is a quadrilateral. Going down this branch, types of quadrilaterals, we could have a kite. Now again, we didn't necessarily go too much into this, but a specific kind of kite, you could have a right kite, which just means there's one right angle in this kite. Again, we went over the properties of a kite, what would be true about it. A right kite has all of those things true. It just also has a right angle right there. Going to our last branch then, quadrilaterals could also be a parallelogram. So essentially there's 4 main types: parallelograms, kites, trapezoids, and irregular quadrilaterals. But then parallelogram breaks down into 2 different kinds: rectangles and rhombuses. Okay, you could have just any old regular parallelogram, but you could get a little more specific and have one that's a rectangle, and we would know some things about that. You could have one that's a rhombus. We would know some information about that. And if a figure happens to be both a rectangle and a rhombus at the same time, then it's called a square. This is the most specific kind of quadrilateral that there is. So this is what our hierarchy looks like. Again, what it means is all squares are rectangles, all squares are rhombuses, all rhombuses are parallelograms, all rectangles are parallelograms. Some rectangles are also squares, some parallelograms, not all parallelograms, but some parallelograms are rhombuses. Some trapezoids are isosceles trapezoids. All isosceles trapezoids have to be trapezoids, things like that. That's kind of what this hierarchy is showing us. It's just a visual aid. So using that visual aid, how many ways can each quadrilateral be classified? So this one right here, we can see, since it's on the grid paper, that this one is straight up and down and this is straight up and down. So this is going to be parallel. Going from this point to this point, we're going down 2 over 1, 2, 3, 4. Same thing, this point to this point, we're going up 2 over 1, 2, 3, 4. So this length, we can see, is the same length as that. If this was a coordinate proof, you'd have to actually use the distance formula to say that. We're just going to visually see or say that, okay, we can tell that those are the same length. So those are congruent then. So what can we say about figure A? Well, it has to be a trapezoid because we have one pair of parallel sides, and it has to be an isosceles trapezoid, so a little more specific. So we can name this 2 ways: trapezoid and isosceles trapezoid. Similarly, here we have a figure going from this point. It's not exactly right on a point, so it's kind of hard to tell, so we're just going to eyeball this one, but it looks like this is parallel to this one, this is parallel to this one, and congruent, 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 congruent. So we've got opposite sides being parallel, we've got all of our sides being the exact same size, but this angle is definitely not the same size as that angle. They're not 90 degrees. So the only things we can really say about this is it's a parallelogram, because all the parallel sides, and it's a rhombus, because all the congruent sides. There's only two ways to define that one. Now again, we can call all of these quadrilaterals, but they kind of already did right here for us, so we don't need to include that one. Let's look at C. Again, we can kind of see just by eyeballing it, this is parallel to this. This is parallel to this. This one is just as long as this one. This is congruent to this. And we can see that these kind of meet each other at right angles, right about here. So this is a little more specific kind of quadrilateral. Looks like it would be both a parallelogram, because of all the parallel sides, congruent sides across from each other, makes it a parallelogram, but because it has these right angles, it's also a rectangle. So this one can be called both a parallelogram and a rectangle. This last one, this side is parallel to that side. They're both going straight up and down. And it looks like these meet at right angles here and here. But we don't necessarily see that this side is the same length as that. So we just have one pair of parallel sides, or two sides that are parallel to each other, and these right angles right here. So all we can really say about it is it's a trapezoid because of the parallel sides, and it's a right trapezoid because of the right angles there and there. Remember, right trapezoid really only means it's a trapezoid with two right angles. So that would be how to name those pieces. Let's go over how to answer always, sometimes, never questions. So using that diagram, using your hierarchy, always means that the first described figure is beneath or right on the second described figure on the same branch. So every one of the first figure you draw has to be the second figure. So if I said a square is a rectangle, let's go back to our hierarchy. Square is below rectangle. So a square always has to be a rectangle. It's always the same thing, as long as it's right below it. Sometimes means the first figure is above the second figure and still on the same branch. So you could draw one of these figures that is the second figure. So if the question was a rectangle is a square, well, I can draw a rectangle like this that isn't a square. So it's not always the same, but I can also draw a rectangle like this that is a square. So sometimes it can be. So because rectangle is above the square on the same branch here, you can kind of follow a line through there, it would be sometimes the same thing. Never would mean the first described figure is on a different branch than the second described figure. So you can't possibly draw the first figure and make it also be the second figure. So if we said a square is a kite, well, square is over here, following it back on either of these branches to quadrilateral, it's on a completely different branch than kites. So a square can never be a kite. That's not possible. So we'd say never in that case. So let's look at some examples of how that works. Have a small version of our hierarchy here. A square right here is a rectangle. Well, it's underneath it, so always, square is always a rectangle. A rectangle is a trapezoid. Rectangle is here. Trapezoid is over here. They're completely different branches, so you can never draw a rectangle that is also a trapezoid, so never. A quadrilateral is a kite. Well, quadrilateral is this top one here. It's above kite. So every kite is a quadrilateral, but not every quadrilateral is a kite. But some of them are. So sometimes a quadrilateral is a kite. Okay? Now that was if we're using exact figures. So quadrilateral, kite, trapezoid, rectangle, square. What if we were using kind of definitions or pieces about them? So if I said a parallelogram with 4 right angles is a figure with all equal sides. Well, a parallelogram with 4 right angles would be describing, I'm going to get rid of some of this. Parallelogram with 4 right angles is describing a rectangle. Okay, that's the highest piece up. That would have to be a rectangle, or I guess it could be a square. Squares also have all right angles. Is a figure with all equal sides. Well, all equal sides is either describing rhombus or square. Squares have all equal sides. So are there some rectangles, so some 4 right angle sides, that also have all equal sides? Yes. Sometimes, not all of them, but sometimes we can have both. So this would be a good example of a sometimes question. So that would be how to answer your always, sometimes, never questions.